Welcome to day 10 of our 12 days of Ec 10. For day 10 and day 11, I'm going to focus on some general purpose critical thinking skills that I think will help you on the final and in Ec 10B in the spring, but will also help you in future Ec classes as well as any other scientific class, so physics, chemistry, biology, basically anything where the scientists use equations to represent kind of what they're doing. And the technique we'll focus on today is called dimensional analysis. Dimensional analysis sounds complicated, but it's actually a pretty simple technique. It means focus on the units. So basically take units seriously. A lot of the time what you'll find is that if you look at the units of what you have on the left-hand side of an equation or the right-hand side or just whatever quantity you're trying to find, and you look at what units it should be in, that'll give you a strong indication of how you're going to actually calculate it. So you're working backwards, like what formula should you use to do it, or you can use the units that are given in the equation and then figure out what the unit will be for the final product, and then you'll get a sense of, what is this equation really used for? What is it going to give me as a final product? So you can use it backward, working from a result to how do I get to it, or forward, taking an equation and figuring out what it's going to give you as an output, the units of the output, and figuring out how can I interpret this output. So we'll give a few examples to demonstrate because it's kind of abstract. Our first example is going to be comparing three concepts that all use the same units. The first is MRS, marginal rate of substitution. The second is the price ratio. And then the third is the opportunity cost. So let me draw in a PPF here. This would be like X and Y. So as you can see, both of these diagrams, the PPF down here and the normal like consumer choice diagram up here, that we studied in chapter 22. So this is chapter 22, this is chapter 3. They're both kind of closely related. They both show you on a horizontal axis one good X. Here it's Pepsi in liters of Pepsi. And then the y-axis shows another good. Here it's chicken wings and it's measured in pounds. And basically, as you remember from the course, the price ratio is the slope of this budget constraint. The MRS is the slope of this indifference curve. Clearly it varies. It's steep here, kind of intermediate right here, and then it's very flat out here. And opportunity cost we could see on our production possibilities diagram. It was the slope of this PPF. So it was very flat here, then it got a little steeper, and then became very steep. Pretty much the opposite of the indifference curve. And since all of these are slopes, their units are always going to be change in the y variable. So here it's change in pounds divided by, well, I guess not change, just pounds, sorry. The formula is change in the y variable, so that has a unit of pounds. So for instance, you change by 1 pound of wings or 2 pounds of wings. And then the denominator was change in the x variable, so here that was be change in liters. So I'm going to make a kind of curly L to make it clear it's an L, not a 1. So the MRS gave us units of pounds per liter. The price ratio is the same, right? Because it's a slope. So it's change in y over change in x. So once again, it's pounds per liter. And then our opportunity cost, if I had called y chicken wings and measured it in pounds, and x Pepsi and measured it in pounds, just like it did for the consumer choice, it would also tell us pounds per liter. So if you ever get confused about, how to calculate the MRS or the price ratio, you should end up with something in pounds per liter or whatever the y good is over the x good. That's useful information. That's the technique I talked about, where if you know the units you should end up with, you can figure out how are you going to calculate to get there. But here, looking at these units, it also gives us insight into what is the meaning of the thing we're calculating. So the formula for price ratio, it's px over py, but what does that tell us? It tells us something about a trade-off of the y good for the x good. It's like, how many pounds do I give up to get a liter of Pepsi? Or vice versa, you could think of it as, how many pounds do I get if I give up some Pepsi? And that's really what the budget constraint is telling us. It's saying as you move from here, where you have a ton of wings, down in this direction, so as I move this way, I get fewer wings, so I give up wings, pounds of wings, but I gain liters of Pepsi as I move in this direction. Or you could read it in reverse. As I move from here upward, I gain pounds of wings, this many pounds of wings, and I give up this much Pepsi. And now you can kind of see how that's related to the marginal rate of substitution. The marginal rate of substitution, instead of telling you what will happen as you move along your actual budget constraint, it tells you what you'd be willing to do. So if you're going to be on this indifference curve, you don't really care where you are, whether you're here, or you move from this point to a point right next to it. You're basically willing to take any of those points, so you would make trades at a rate of substitution, hence the name, of where you give up whatever MRS is pounds in order to get some liters of Pepsi. Or you could read it the other way, you give up, you get some number of pounds in exchange for a liter of Pepsi. You can sort of read it in either direction, just like with the budget constraint, as you move down or as you move up. And now we can see how both of these are closely related to the opportunity cost. The price ratio is basically telling you an opportunity cost as you move along your budget constraint. What will I actually have to give up on my budget? The MRS is telling you what would I be willing to give up. And then the production possibilities frontier, just like the budget constraint, tells you what would you actually have to give up. That's why when you did the problem set, I think it was number 3 on problem set 7 about Robinson and Roberta, your budget constraint was your PPF, because they both really basically tell you similar information. They tell you what is it possible for me to consume. So our next example illustrates how you can use dimensional analysis to make sense of graphs. Sometimes people are tempted to like shade in something. We shade in stuff a lot and sometimes do it without thinking very much. So they say, if we label our diagram here, this is QD. It's where the price intersects demand. So people want to buy this much given the world price here. And then the firms want to supply this much on their supply curve given this world price. So this would be QS. And now they look at this and say, oh, I see that we're going to import some stuff because QD is greater than QS. So let me just shade in this like blue area. Is that right? We always like to shade stuff. This kind of looks like the right thing you'd want to shade for exports. But look at the units. The units, when you shade that area in, it's some vertical distance measured in pounds or dollars per pound times some horizontal distance measured in pounds. So we're using chicken wings as the example again, in case that wasn't clear. And then these pounds cancel out, so we're just left with dollars. Do we measure the amount of chicken wings you imported in terms of dollars? It seems like you might, except the answers you've always given have been like numbers of chicken wings, pounds of chicken wings. So the answer we want to see is not going to be in dollars. An area wouldn't really make sense as an answer. And it doesn't really, when you look at the units, now it's very clear you don't want to be shading in some area. If you're looking for how much you import or export, it's just a vertical distance. It's like this, let me put it in green. It's from here to here. It's only in one dimension. It's QD minus QS, so that just leaves you in units of pounds minus pounds gives you pounds, some number of pounds. A third example, we can think about, like, why are we always shading stuff in to calculate producer, consumer, surplus, externalities, and so on? And as hinted on the previous slide, it's because if you shade in some area, like what I'm going to shade in is in green here, this would be our typical consumer surplus, right? And you can see how it's some vertical distance in dollars per pound times some horizontal distance measured in pounds. The pounds cancel and you're just left with dollars. So consumer surplus tells us in terms of dollars how much surplus or how much like richer is the consumer, basically. Literally, it's trying to answer the question of, by allowing you to trade, how much richer have I made you? If I took away your ability to trade, how much money would I have to give you to compensate, and specifically how many dollars? And that's why it would be naturally measured in dollars. Producer surplus is the same, right? It's also, we expect, measured in dollars, and it's a vertical distance here times a horizontal distance here. So naturally, it is also measured in dollars, and it answers the question of how much money, basically how much profit did you make by being able to trade in this market. It's not completely identical to our notion of economic profit because it excludes fixed cost, but it's really similar. And our units, I think, give us a lot of intuition into, why we're shading areas as opposed to, just distances on the graph, like with imports and exports. So then finally, I think a great application of this sort of thinking in terms of units is how you can remember the price ratio is px over py. A lot of people find that counterintuitive, and the sort of like long way to derive it is to just graph out our budget constraints. So here I've drawn it in. It doesn't look like a straight line, but that's just because my hands shake, so I couldn't draw it straight. We know that this point at the top of the budget constraint, let me use my highlighter. This point right here is how much Y you could buy of good Y if you spent all of your money on good Y and had 0 of good X. That would be your entire income divided by, so income on the numerator divided by the price, PY. So this is definitely the right quantity for Y. Similarly for X. Now if we want to calculate slope, which is what we call, we said the price ratio is the slope of this thing, it would be, the change in Y would be I divided by PY. And the change in X would be I divided by PX. And you can see how the I here cancels with this I, and then you're dividing by a fraction so that this comes up, the PX comes up to the numerator, and you get PX over PY. So that's the long way to derive this. The second way to think about it is just in terms of units. The units of PX over PY are dollars per X divided by dollars per Y. So you get Y's over X's. And we know that the price ratio, the slope here, as discussed earlier, it's telling us like how many Y's are we giving up to get X's, or the other way to look at it is how many Y's are we getting in exchange for giving up an X. And either way we look at it, we know that we should be seeing Y's over X's as the units. Just like earlier, in the earlier example, it was pounds of chicken wings per liter of Pepsi. And by looking at the units, it's clear that we're only going to get the right units if we do PX over PY. So in summary, dimensional analysis is taking units seriously. Units have a lot to tell you. They tell you about why the product, like what is the meaning of the product you're calculating if you know the formula. If you don't know the formula, just looking at what you should end up with tells you a lot about what formula you need to use to get there. We discussed specifically how budget constraint, marginal rate of substitution, so not really budget constraint, but the slope of the budget constraint, and the opportunity cost. So I guess actually this should just be a OC. So the opportunity cost, marginal rate of substitution, and price ratio all tell you about trade-offs. That's why they all share the same units. They're telling you about giving up some Y in order to get some X, or conversely, how much Y you're going to get if you give up one X. PS, CS, deadweight loss, etc. are all measured in dollars. They're all areas because it's dollars per unit times units. And they're all thinking about some thought experiment like trade allows you to get some benefit, and I want to measure how good that is, because if I took it away, how much money would I have to give you to compensate you? And then last, I'll leave you with a question. Whenever we shade in a revenue or a profit on the diagram, it's always an area. Why is that? Why is profit always a box and not a line? Why is revenue always a box and not like a line? And after I leave you with that question, I'll just say a few words. There's only 2 days left now before the final. If you're watching this early, because I'm going to post it early, there might be 3 or 4 days. But I really encourage you to, stay in touch, ask questions. You probably have built up a bank of difficult questions that you're reviewing, and you might just need a little bit of help to understand that one like trick part of that question, or that key insight to that old problem set question that never really made sense. And that's really what office hours are for. That's what meetings are for, review sessions are for. So please try to attend those and make the best use of your time. Thanks for watching.